Welcome. This video covers more about ggplot2, including faceting, themes, and ggplot extensions. Let's start with the idea of faceting. Faceting is a really powerful idea that allows us to create a lot of plots that are very similar to one another. Now consider this side-by-side bar plot that we made previously. What if I wanted to recreate this same exact bar plot, but I wanted to do it for each of my categories for another categorical variable? So this myEmbarked variable had 3 levels to it. I want to create this same side-by-side bar plot for each level of that variable. Well, that's not hard to do. All we need to do, we take this same exact code that we have here, and then we can use either facet wrap or facet grid. Facet wrap, what it does is you just tell it which variable you want to use after a tilde, and it's going to create a plot for each setting of that variable. So this should be a categorical variable here. And you can specify how many, so it's going to create a bunch of plots. And so sometimes it's going to need to drop down and put them below. And so you can specify how many rows of plots you'd want and how many columns you'd want, or what most people do unless they have some constraints is just let R figure it out when you use facet wrap. R will look at how much space it has in the plotting output window and try to figure out what to do based off of that. Alternatively, you can use facet grid, and facet grid is a way to just make sure that you have things across a grid of values. And so facet grid works in the same way. You just give it the variable that you want across the rows first, and then tilde the variable you want across the columns second. And again, these should both be categorical variables. If you just want to create, say, a column of plots or a row of plots and just make sure it stays as a row or a column, and you can use facet grid here and just use a period on one side or the other. So if I want to have a column of plots, I could use period tilde var2. If I wanted a row of plots, I could use var1 tilde period. Here's an example of using facet wrap on that previous plot. We're going to use the same exact plot that we had, but now we're going to add another layer. And the layer we're going to add is a facet wrap layer. I'm going to say facet wrap tilde myEmbarked. And so what that does is R says, okay, you want a plot for every level of this myEmbarked variable. No problem. I'll just go ahead and put those next to each other because there's enough room to do that. And this gives us a way to not only compare the distributions of the mySurvived and sex variables, but now also we can compare that across the myEmbarked variable. Essentially, we get a way to look at a three-way contingency table with graphs. All right. Again, faceting can be used across any of the plots that we've done. We created those box plots previously, and we added the jittered points on top. Well, now I'm just going to add a facet wrap layer, and I'm going to look at those same plots, but across, again, the myEmbarked variable. And this gives me a lot more information. I now know that this Queenstown port, this was very different than these other two. And most people got on at Southampton. So I'm getting lots of information based off of these plots. Another example where we're using faceting here would be on the scatter plots that we made previously. This is actually slightly different. So here I'm going to do x equal age, y equal fair, but then I'm going to color the points by the sex variable. And I'm going to now add a facet wrap layer, so I get that same plot across every embarked port. And you might notice that all of these aesthetics that we're doing here, all of these get applied to every plot, right? They get applied there, they get applied there, and they get applied there. So we don't have to remake the plot ourselves. We don't have to subset the data ourselves. Faceting is doing all that for us, and it's recreating that same exact graph for each one of those subsets. Pretty powerful stuff. All right, faceting will be great. Another thing that's really useful to know about is the idea of ggplot2 themes. Themes just change the general look of your plots. And there are lots of different themes that you can have. One of them, for instance, is theme light. Notice what I'm doing here. I'm just adding a new layer, and this layer is just describing the theme of my plot. And so the light theme just changes the background. Looks kind of nice. There's lots of other themes. If you're going to put your plot on a web page, sometimes it's really nice to have a dark theme. So here I'm going to use theme dark. And now I get a darker background, and the points sort of pop out of that. There's an area on the cheat sheet down at the bottom that gives some of the basic themes down here. However, there are lots of other themes that are available through other packages as well. Let's talk about the idea of ggplot2 extensions. Like I said, ggplot2 is such a popular package that people have built extension packages for it to do all sorts of fun stuff. So for instance, there's a ggally package, and again, case sensitive, so gg for some reason they made capital, but ggally has a ggpairs function, which is really useful for just exploring a data set. I can install that package and then read it in, and now I can use ggpairs instead of ggplot. I could use the same exact types of arguments though. Titanic data is my data set. My aesthetics I'm mapping from my, actually I put this within the AES, but that could go outside. But I'm mapping the sex variable to color, and then I'm specifying that the columns, the variables that I actually want to summarize here, and it's just going to create all possible summaries between those down below. And so you get lots and lots of useful information. This is a great way to just sort of get a glimpse of your data and the relationship between the variables that you have. Other extensions, again, there are lots of them. There's over 100 registered extensions here if you go to this website. And you can scroll down here and see that there are tons and tons of these things. And you can actually search through them. There's 102 registered extensions at this particular moment in time. And so one of them we'll look at here in just a second is this ggAnimate. And we'll just recreate this example. This allows us to create GIFs, or GIFs if you will, very easily. Let's see this ggAnimate package and how you can use it to create a GIF. So you would need to install this package, and I'm going to use this data set that they used on their example, Gapminder. So it's actually a package called Gapminder that you can install, and then you just do library Gapminder and you'll gain access to this Gapminder object. Again, I had to install ggAnimate, but now I read it in. I also had to install this GIFSKI package in order to get this GIFSKI renderer down here. So you might need to do that as well if you want to follow along with this example. But what we're going to do here is use the same kind of ggplot code that we did before. So all of this that you see right here, this is just ggplot code. Everything that we've done before is there, except they're also messing around with the scales quite a bit. So we didn't really cover that, but they're just changing the values that show up there on the scales. The part that is specific to the ggAnimate package is given below. So you might notice that this is kind of a weird thing. This is how they're changing the title over time. They're using these curly brackets and using frame time. And so that's a special thing for the ggAnimate package. And then they're using transition time as an additional layer to say, I want to transition across the years. So we're going to create the same plot, but across years over time. And then it's going to be a linear transition. So I save that as an object called GIF. And then I'm going to use animsave, which again is from the ggAnimate package, to actually just save that as a file that then I can read in and look at. And so here's the GIF that gets made here. We have our just basic scatter plots faceted across these variables, but then notice that it is changing across the years, right? We did that transition through years, and so that's what it's changing. So it's creating that same faceted bunch of scatter plots for every single year and just putting them one right after another. It's a really cool addition to ggplot. And again, there's over 100 registered extensions, so there's lots of different things that you can do. There's lots of examples out there that you can follow along with and try to mimic. All right, let's jump into R and play around with the faceting and the themes. All right, let's create a section for faceting and themes. What's really nice, again, is that we can just take the plots that we made previously, and if we want to create those same plots across categorical variables, we just add faceting layers. So I'll grab this first stacked bar plot that we made up top, and I'm going to go ahead and just add a layer. Some of the other variables that we had in here, we'll use Faceting Grid just to make sure we see that functionality. We had that hormone variable, which I think was hormone, and there was a grade 2 variable, I believe. So bring this up. There's a grad 2, which I think is just another version of that grade variable. So let's go ahead and make that a factor. Let's use grad 1. Maybe that's more important. I don't really exactly know what these variables are, which is not great, but we can still at least see the functionality here. Let's run that. We got our grid, so we're going to have the hormone variables across our rows and the grad variables across our columns. And so looks like grad 1 had two values, 0 and 1, and then the hormone variable had two levels. And so now we're getting those same plots across each one of those. And so we're definitely getting some information. There's probably some relationship between the grade and then the grad 1 variables, because we're seeing only grade 1 over here and only grade 2 and 3 over here. Let's go ahead and grab the scatter plot that we just made, and we'll do some faceting and then also check out some themes. This one will be a little easier. We'll just facet wrap this one. Facet wrap based off of the, let's do the hormone variable. Hormones. Forgot to run my G object, so I'm still using this previous G object, and it says, that doesn't make sense. So I got to rerun this G object. And now I get that same scatter plot across these two hormone variable levels, which is great. Let's also change the theme. Let's do theme classic. Oh no, this looks like our plots that I used to make 10 years ago. Lovely. But again, this is how easy it is to use ggplot, and this is why it's become so popular. You can take very basic plots and then just add some layers, and you get a lot more information without having to do a lot of work. And again, it's automating all of this stuff for us. It's automating the creation of these labels. It's automatically adding these trend lines with colors and confidence bounds and things like that. It's just a really, really nice way to do your plotting. So that wraps up our discussion of ggplot2 for plotting. This is a really great package for creating publication-ready plots. I know it has quite a bit of a learning curve to it, but there is this package called Esquisse. I believe it's French. And so if you install that package, it actually will give you a visual way of creating these ggplots, and it will actually produce the code in the corner, kind of like that import menu that we looked at one time. You'll be able to drag and drop different areas to get what the plots that you want to see, and then it'll produce the code that made it. That code will not look like exactly like the code that we made, but it is a nice way to get started if you are more of a visual learner. And just generally a bigger recap of this section, right? We are talking about how to summarize data. How do we get meaningful insights from our data? Well, we need to understand what kinds of data we have, numeric or categorical. And with both of those, we want to describe the distribution. We can do so numerically and graphically.